Hi, everyone. It's great to be speaking with you today about semantic search. My name is Dustin Coates, and I'm the Principal Product Manager for Search Ranking and Semantic Search at Algolia. We'll be going deep today on a few different topics. First, we'll talk about what semantic search is. Then we'll separate the reality from the hype. There's a whole lot of hype, so we really want to focus on what's real. We'll also talk about what semantic search solves. If semantic search was interesting, but it didn't solve anything, it wouldn't really be that interesting. Next, a look at some of the components that go into semantic search. And finally, we'll talk about some exciting semantic search news from Algolia. Now, what is semantic search? Semantic search is search with understanding. Search queries that would have otherwise had poor results instead are useful to searchers because the search engine intelligence can find relevant results. Let's look at an example. What do you mean when you search for Terminal 5? You could mean one of the terminals at JFK in New York City, or at London Heathrow, or maybe even, if we head back to New York, the music venue in Manhattan. Semantic search can help us get to what the searcher really wanted. Put another way, search queries follow this kind of distribution, where you have popular queries called head queries that are seen the most often. These are queries that are generally very broad, like vacuum. Then you have queries that are less popular, or long-tail queries. These tend to be longer and more precise, such as red vertical bagless vacuum, but that's not always the case. The query mop would be a long-tail query on a site that only sells vacuums because not many people are searching for a mop. Because long-tail queries tend to be longer and more complex, keyword searching will often break down. All it takes for many search engines is for a searcher to add one keyword that's not found in the records and no records come back. However, because head queries are so popular, it's even more important to get the right results back to searchers for these queries. Now let's talk about what semantic search is and what it isn't. We see semantic search as a way to solve problems, and that's important because when we understand users, then they're happier and they convert more often. Relatedly, semantic search is a way to understand what users really want to find. Our entire goal is to make it so that we understand users, and users don't have to understand the search engine in order to be successful. Finally, we truly believe that semantic search is the future of search in the next decade. Improved machine learning has made semantic search something that it can improve all kinds of search experiences. If we look instead at what semantic search is not, it is not a marketing term. Or I should say it should not be a marketing term. Too often today, search engines will say they have semantic search and it's nothing of the sort. It's also not a technology. Often semantic search is used as a synonym for vector search, but it is much more than that. And finally, it is not a silver bullet. As we'll discuss, there are times when traditional keyword search still is the right choice. The challenge is knowing when to go with keyword search and when a more ML-driven approach is necessary. Let's now take a look at some semantic search components, starting with natural language processing and natural language understanding. A few semantic search components in this bucket are normalization and tokenization, typo tolerance and spelling correction, and named entity recognition. Starting with normalization and tokenization. You'll generally hear people who work with search engines refer not to words, but to tokens. The reason for this is that words are often incomplete when trying to find information. Just look at this example. Women's is a single word, but it's actually implying more. It's implying a relationship or ownership between women and shoes. This is also true for contractions like isn't or aren't, so we break words into their constituent parts. By the way, this is even more true in some languages other than English, like German, where you can smash words together to make mega words. Also notice that we lowercase everything, which is a type of normalization. There's no reason that women with a capital W shouldn't match women with a lowercase w, so we just make everything lowercase. Next up is typo tolerance and spelling correction. One way to do typo tolerance is with machine learning. It's powerful and can work really well, but it has some drawbacks, especially for search queries. A query with just a couple of tokens doesn't provide enough context to know the correct spelling. Take this query of woman's shoes. Did the searcher actually want to type woman's shoes, or maybe women's shoes, or even women's shows? That's why at Algolia we use something called edit distance. If there are records that have woman's shoes, that's an edit distance of 0. It doesn't need to be changed at all. And that is considered more relevant than records that have women's shoes, which is more relevant than women's shows. Finally, for natural language, there is named entity recognition. Named entity recognition will identify important items or entities in a text. Here we can see that perhaps Houston refers to a city and Tex-Mex to a type of food. Recognizing these entities can be helpful for doing things like automatically filtering down on or boosting search results in order to be more precise in what we return to searchers. Indeed, that's what you can do within Algolia using filter rules. Next up, we have a couple of components around query expansion and relaxation, synonyms and alternatives, and query word removal. Synonyms and alternatives say that this token is equivalent to this other token. In the example of summary dresses, synonyms for summary might be lightweight, airy, or even gingham, because that's what you wear in the summer. Alternatives are other tokens that are equivalent but not synonyms. For example, within Algolia, you can ignore plurals and say that dresses and dress are effectively the same thing. And you know what? For search, they are. Remember, we are trying to understand users, not make them guess whether the plural or singular form is contained within the records. Synonyms and alternatives expand the number of records we are returning, or the recall. Another way to increase the recall is by removing query words. You most often will want to do this when a searcher's query returns no or few results. But how to know which words to remove? One way might be again to use machine learning, identifying the words that are most or least important in the query and remove those least important words. Maybe we can remove large because all smartphones are large these days. Maybe red because we think that people are fine looking at other colors or if there are no red phones available. And maybe smartphones because Android and smartphones are already fairly equivalent. The problem with the machine learning approach is that there is too much of a chance of getting it wrong. What we do at Algolia instead is to give you the choice to remove words iteratively from the beginning or the end of the query until you get results. Alternatively, you can just say that all words in the query are optional and records just need to match a single word. This is the option that's most commonly used. Now we've applied those components and we want to get the best results at the top. Textual relevance can do a lot, but what is relevant for one person will be different from another. And what's relevant at one part of the year will be different from another part of the year. That's where re-ranking and personalization are useful. Both of these take searcher interactions like clicks and conversions and use them to change the order of results. The difference between the two is that re-ranking is across all searchers and personalization is for a single searcher. If I'm the searcher, I want to see rain jackets in the spring just like everybody else. And I want to see red jackets because red is my favorite color. And now we come to the big one, vector search. Earlier I told you that semantic search is not just vector search. And yet vector search can be a big part of semantic search. It's also probably the one that's most difficult to understand if you haven't encountered it before. So let's look at just what vector search is. Vector search is deep learning driven and it attempts to use machine learning to reduce items like text or queries to their core numeric representations using vectors. Then vector search uses math and geometry to determine which items are most similar based on their vectors. Sometimes when we look at examples, we can get too hung up on the items themselves, so we're going to use 3 made-up words: Waddlesmarf, Lunzel, and anti-matrimonium. Now, which of these two are the most similar? Let's use vector search to find out. Underneath each word is their numerical representations. These columns could refer to specific attributes, for example, whether a word is positive or negative. But what's very important and very interesting is that we do not define these attributes ourselves. The neural network figures these out on its own. Also important to note is that a typical vector will have dozens upon dozens of numbers within it. To make it simpler for us, we'll look at just 2 numbers for each word. Now, do we know which 2 are the most similar? We still don't. So let's do what vector search more or less is doing and graph these points. This is where geometry comes in. Once we graph these points, we can figure out a line that goes in between each of those points and look at the distance between those lines. Doing that, we can see that Wattle, Smarf, and Anti-Mashimonian are the 2 that are the most similar. The effect here is that we can find items that are conceptually similar even if they aren't textually similar. No keyword search engine would ever match any of these 3 words to the other ones. This allows us to increase our recall and find more relevant records. We can then use these similarity metrics to rank the results without leaving keyword matches behind. For example, if someone searches for SFO, then a record that contains SFO is a better match than one that contains San Francisco Airport. So we want a blend of keyword and vector search. This is why we are so excited to welcome Search.io to Algolia. You may have heard this news in the keynote earlier today. Search.io has a unique approach to semantic search called neural search. Neural search combines vector search and keyword-based search and returns relevant results in milliseconds. The combination of vector search and keyword-based search has the benefit of returning great search relevance on short-tail queries like vacuum and on long-tail queries like upright bagless vacuum. We will be working hard to integrate neural search in Algolia and are excited to tell you more about it in the coming months. Now, to summarize. Semantic search is a way to solve a problem. Semantic search is how we better understand user intent. Semantic search is the future of search in the next decade. Semantic search is not or should not be a marketing term. Semantic search is not a single technology. And semantic search is not a silver bullet and should be mixed with a more traditional keyword search. What's next for you if you're interested in semantic search? Step 1, simplest. Turn on those NLP settings like ignore plurals and remove stop words. Step 2, turn on query expansion, namely remove words of no results. Step 3, add your synonyms and alternatives. By the way, a great tool to power up your synonyms is using Algolia's AI synonym suggestions, which will suggest new additions based on searcher behavior. Step 4, set up dynamic re-ranking and personalization. We've seen over and over the positive impacts that these features have on conversion rates. Finally, step 5, follow us to learn more. We have a lot to tell you over the next year and can't wait for you to try what we're working on and get your hands on neural search. Thank you so much for listening, and if you have any questions at all, please feel free to reach out via what you see on the screen. Thanks again, and hope you enjoy.